Hello everybody and welcome back to 3DAF. My name is Zander and today we're going to dive even deeper into the manufacturing process. So up until this point, our channel has really revolved around 3D printing and art and so on, and that's awesome. And we're going to keep doing that. But over the past year, I've had a lot of people come up and approach me both in person and online saying, hey Zander, you know, it's hard to find information about how machining works, whether it's 3D printing, milling, lathing, grinding, EDM, so on and so forth. So over the course of this new series of episodes, we are going to explode and explore all these different ideas and concepts. So we need to start at the very beginning. And where does it begin? Well, machine tools have been around for a long time, like really long time, depending on how you want to debate it out. Everything from cavemen using simple drills all the way up to the Industrial Revolution really includes what we would consider machine tools. But for the purpose of today's episode, we are going to focus on computer numeracy controlled machines as we begin to explore geometric G-code programming. Now, with that being said, today we are going to look into what are G-codes, how are G-codes used, what kind of G-codes operations are there? What is modal? I mean, like, what is modal? For reals, though. Put your guesses in the comments, or if you know, snicker to yourself about it. And we need to look at why they are important in modern manufacturing when software drives most of the G-code programming. So, without further ado, let's get into it. So what are G-codes anyways? Well, G-codes, or geometric codes, were developed by MIT Servo Mechanisms Lab in the 1950s as a way to relay information to a computer numeracy controlled or a numeracy controlled machine in such a way that it would have predictable results. That's amazing. That's the basis of all of our modern manufacturing right there, is to have a code-driven system that gives the desired results, preferably every time. G-codes are a preparatory code that determine the kind of motion or action that will occur when they're executed. The language's primary codes allow a machine to move in a variety of different patterns and can cycles. Although it's called the G-code language, or G-codes in general, the system includes G-codes, M-codes, and words, which are not words like we would think of them. They're typically individual letters that are short form for words that help control the different actions that the G-codes will do, such as F for speed, S for spindle speed, axial codes like X, Y, Z, A, B, C, and so on and so on. And now to talk about how G-codes are used. Each G-code has an assigned operation that it follows, and many codes have additional words that can modify how that code will work. For example, G03, which is a counterclockwise arc, can be controlled with I, J, and K to control the arc in different quadrants, R to control the arc overall, and of course you're going to need the F word on there, it's not going to know how fast to go. G-codes are written in sequence with their support words to make this complete sequences or sentences, which will end in an and a bar or semicolon, or I've even run one really cute machine where it was a heart. Typically on most controllers, 5 codes can be used in a single sentence, but modern machines are starting to do away with this because it's a constraint that just really doesn't need to be there. Now let's take a second to talk about which kind of G-code operations there are. Now, first of all, I'm going to throw this out there. This is not an all-inclusive list, and we are going to be addressing a lot of these individually to talk about how they work, how the words control them, and so on in further episodes. This is an absolutely elementary level covering of this. Most of the main codes within the G-code language are used in 4 different groups. So we have the motion control group. That's your G00, G01, 2, 3, G90, G91. These ones control how motion's going to work, whether you're rapiding with G00 or linear interpolation with G01, or arcing with O2 and O3. It's all about how you're going to move. And they're used in coordination with Cartesian planes, which we'll talk about a lot more later on. Then we have offset controls. So offset controls set tool offsets and tool heights and such things, and encompass G40, 41, 42, 43, 49, so on. Then we have datum controls. So datum controls specify where your part is and how your part is going to be machined from a datum point. And they're typically G54 to G59, although some more modern state-of-the-art machines allow you to have almost infinite part locations within them, especially outside of conventional machining, such as EDM and 3D printing. Beyond that, we have cant cycles, which are used for drilling, tapping, so on and so forth, and they're mostly found in the G80 to G89 range. And now, it's time to talk about modal codes. So, modal codes are codes that stay in effect until they're canceled or overridden. Pretty simple. There are both specific cancel codes and overriding codes. For example, if you're rapiding around at G00, woo, and you throw a G01 in there, it will cancel the G00, and you'll be moving in linear interpolation, which will move all the axes at the same time to arrive at the point in a stepping motion. Actions like G02 and G03 work very much the same way. Beyond that, we have codes like G20 and 21 that set metric or imperial stepping motion. We have tooling offsets, G41, 42, 43, that are going to stay into effect until they're canceled, typically at the end of that tool. Beyond that, your coordinate offsets, your G54 to G59, will also stay modal until changed or canceled. And there are a few extras there, including cant cycles. Now we need to look at why it's important to learn G-coding in a software-driven era. For most people who are familiar with CNC programming, represent CNC programmers out there watching this, you know that the software that you use writes through G-code. It comes right out like that, and if you've got the right post-processor, you're ready to sail after getting through your programming routines. But there are still many shops out there who still write G-codes like I did back when I was just starting out in the machine trade in the controller to run small programs. Or have to go in and fix, modify, change, or improve G-codes. And in order to do that, you really need to have a good understanding of what each of these operations are going to do. And that is going to be the subject of our future episodes. We are going to start talking about what each one of these operations does, how to use it in a very effective way, and how to improve your programs through knowledge. Now, this information can also help further in developing post-processors for new machines, which is just a language that translates things into a G-code that machine can understand. And we're going to talk about some of the differences and variances in G-code for different types of machine tools. So, stay tuned, like, subscribe, and check out the rest of our videos too, because we're genuinely just a cool cat operation here. Thank you for your time, and we look forward to seeing you again in the next episode where we're going to talk about codes. I'd like to take this moment at the end to just thank our longtime viewers, subscribers, and all those people who watch all of our stuff. You know who you are. For those of you who don't actually know us personally, we've been going through a huge move over the last year. We've gotten into a new facility that's just got incredibly more space. And we're going to start building all kinds of new projects. We want you to be there for that. We're going to bring you in. You're going to see how to do it. You can follow along with us. We are going to cover exciting new topics like machining, G-code programming, and all kinds of new manufacturing technology. And stay true blue to our 3D printing videos that we've already been doing. So like, subscribe, hit that notification bell, and don't miss one single episode with us because it's always going to be at least funny, if not good information. Thank you, and good night, everybody.